Hello guys, in this video I'm gonna show you, an example or solve an example that you can solve a circuit that you can solve using basically the basic laws, Kirchhoff voltage law and Kirchhoff current law, and of course Ohm's law as well. So let's start in here. So we have here a circuit. We have three resistances, 2 kilo ohms, 3.3 kilo ohms, and 1 kilo ohm. Okay, we have a voltage source of 9 volt in here. And we have a current source here with 1.8 milliamperes. Okay, so one note here: once you find the currents is in milliamperes and all the resistors are in kilo ohms, don't convert. Don't convert milliampere to ampere, and don't convert kilo ohm to ohm. Okay, just keep it as it is, because the values of the current will be much smaller, the values of the resistances will be much higher. You're gonna confuse yourself. You're gonna have many errors in your calculations. So please don't do that. So when we deal with electric circuit, we deal with either ohm and the current, or milli ohm and the kilo ohm. Ampere or ohm at the same time, or milliampere and the kilo ohm at the same time. Don't mix now. So if you find ampere and kilo ohm, convert one of them to either convert the ampere to milliampere or convert to the kilo ohm to ohms, But ampere with ohms or milliamperes with kilo ohms. If you notice here, if you convert milliampere to ampere, this will be like that. So small. This, for example, will be like that. Too big. So keep it with milliampere and kilo ohm. That's the first point. Okay? Good. Now, we have also something new that we didn't study before. Ground. The thing in here. So this point here has a value, a voltage of 0. So ground has like two symbols. It can come like that or like that. Both are ground, so don't worry. Both are called ground. And a ground point has a voltage equal to 0. We can, explain this, in a separate video, but this is basically it. And a ground makes your solution easier, much easier actually. In many cases, much easier. And in the future, I'm gonna teach you that you can do that yourself. Even if the circuit was given without a ground, you can put a ground. And there is like a logic for that, a very strong logic actually. Good. So that's a point, and that's another point. We didn't solve the solution, so we didn't solve it. So let's now start solving. Okay. So I'm gonna here do a solution, which is basically a more difficult one. In the next video, I'm gonna do a much easier one. So first of all, let's check this point here. Okay, let's call it, for example, V. At node V, we have three branches. We have a branch with a current I1, a branch with a current I2, a branch with a current I3. So as we said in Kirchhoff current law, the amount or the sum of all currents is equal to 0, or we can say the sum of the current that is exiting the node equal to the sum of the current that's entering in the node. All the currents here are exiting the node, so you can just add them together. So applying KCL, Kirchhoff current law, or Kirchhoff current law, whatever you call it, I1 plus I2 plus I3 equal to 0. That's very good. Let's now take this branch. Where is I3 is flowing? I3 is flowing like that. This is Mr. I3. It's flowing like that. Oh, and where is the 1.8 milliampere flowing? It's flowing like that. In the same branch of I3, but in an opposite direction. And we learn that same branch, two currents, they are the same. If they are opposite, that means one of them is the negative of the other. But they are the same. Okay? So in the branch of the 1.8 milliampere, I3 is actually equal to minus 1.8 milliampere. And keep it again in milliampere because all the resistances are in kilo ohms. And based on that, we can substitute here. So I1 plus I2 plus I3. I3 is minus 1.8, so minus 1.8 equal to 0. So from that, I1 plus I2 equal to 1.8 milliamperes. And call this number 1. Because we have two unknowns, I1 and I2, and we have just one equation so far. So we need another equation. That's very good, very good. Let's now take or look at this loop here. I'm gonna call it loop 1. What are the voltages in loop 1? Okay, so let's see. So we have the battery. The battery has a negative. This is the negative of the battery, and this is the positive here. So the voltage of the battery is like that. I1 is flowing like that. And we said in a resistance, the voltage, you can assume it whatever, but usually we assume the voltage opposite to the current. So I'm gonna assume the voltage like that. We're gonna call it, for example, let's call it V1. Because this is I1, so let's call it V1. Good. And let's now look at the resistance 3.3 kilo ohm in the middle here. So I2 is flowing like that in it. So again, the voltage is like that. And let's call it V2. So in loop 1, we have the 9 volt, we have V1, and we have V2. Okay? And let's assume this direction that I did here is basically this direction here is the positive direction. We're gonna apply KVL, and again, you can choose whatever you like. Here I choose the clockwise direction as positive. You can choose the negative, the counter clockwise as positive, whatever you like. It will be lead to the same like result. That's very good. So based on that, let's check. So the 9 volt has the same, direction as our positive direction. So this will be positive. Then V1 also in the same direction, so plus V1. Now let's come to V2. V2 is opposite. So V2 is going in this way from left to right. Our positive direction, the clockwise direction is going from right to left. So minus V2 is equal to 0. So what is V1? V1 is IR, the resistance multiplied by the current. V1 is actually the voltage of the 2.2 kilo ohm that has the current I1. So V1 is equal to I1 multiplied by 2.2. Look, guys, here, this is what I said in the beginning. The milliampere and the kilo ohm will cancel each other, so don't worry. Okay? Here I1 is in milliamp because I assumed all the currents in milliampere. And 2.2 is a 2.2 kilo ohm. So when you multiply them together, the milli will go with the kilo, they cancel each other, and you're gonna have at the end of the day, ampere and ohm. So it's okay, which is volt. Okay, and similarly V2 is equal to I2 multiplied by the resistance 3.3, and again 3.3 kilo, and I2 is in milli, so they are good. So let's now substitute. So 9 plus V1. V1 is 2.2 I1 minus V2. So 3.3 I2 equal to 0. Oh, look at this equation here. The two unknowns, it has two unknowns, and the two unknowns are I1 and I2. Oh, so we get another equation for the first equation. So just write it in a neat way. So we can say here 2.2 I1 minus 3.3 I2 equal to minus 9. That's number 2. That's number 2. Okay. So let's now, so we have two equations, two unknown, two linear equations and two unknowns. So you can solve it using your calculator. I usually use some online tool. I'm gonna teach it to you right now, and you're gonna find the link for this tool in the description. So let me bring this up in here. Okay, guys. So I brought up the, Desmos online calculator. So Desmos has like many tools online. One of them is called, I believe, matrix calculator. So you can find all the tools here. So that's the matrix calculator in here. Okay, I'm gonna teach you now how to do that. Okay, so we have two equations and two unknowns. Okay, so I'm gonna define a matrix called A. So I'm gonna click on A here, then equal from your keyboard, then new matrix. The default is 2 by 2, so we are good. If it's 3 by 3, so you're gonna increase the number of rows and the number of columns. Okay, so the first equation, as you see here, I1 and I2 both have 1. So 1, and the second element is 1. Just, follow what I'm doing. You don't need to understand. This is linear algebra, but it's okay. Okay, now the second row, which is basically the second equation, 2.2 for I1 and minus 3.3 for I2. That's, A. Now, look, I didn't put so far 1.8 and minus 9. We're going to put this in another matrix called B. B has two values only. So it's two rows, one column. Okay. So B equal from the keyboard, new matrix. Oh, this matrix 2 by 2. Make it two rows by one column. So decrease the number of columns like that. And in the first element, you should put 1.8. The second element, you should put minus 9. Okay. Again, this is linear algebra, but it's very easy. Don't worry. Just follow what I'm doing. You can, if you have a calculator that can solve equations, that's also good. Equal. Now, what we should do, we should multiply a minus 1 by b. What a minus 1 means a, the matrix A to the power of minus 1. Don't confuse yourself. Just follow what I'm doing. So a, the matrix A to the power of minus 1. Okay, matrix A here. Then you should click here, multiplied by B, the matrix B. Good, that's it. So that's I1 and that's I2. One common mistake here that people usually do, you should stick to the order. So here you mentioned in the first equation I1 plus I2. So in the second equation, it should be also something multiplied by I1 plus something multiplied by I2. Okay? And of course, don't neglect the sign. So I2 here in the second equation has a negative, so I put negative. Okay, guys, very easy. So that's I1 and that's I2. So let's, I believe we can copy and paste. So that we can just write it. So that's fine. So I1 equal to minus 5, 5, 6. You can just take 3. That's fine. Or even 2. That's very fine also. 2.356 milliamperes here, milliamperes here. That's it. That's Desmos. If you didn't get it, just rewatch the video. Okay. I have also a separate video for that only. Good, guys. That's basically very good. So we could find I1 and I2. That's not the end of the day, because in that question, it was asking for, sorry, that's I1 and I2, but that's not all, because in that question, it was asking for V1, this guy. The voltage, this V1, the voltage across the current source. Okay, V1. Let's even write it in that way. In red, so it is recognizable. Okay, V1. So we need to find the V1. So V1 is part of that loop. This is the second loop, the bottom loop. Okay, so I'm gonna put or apply Kirchhoff voltage law for the second loop. The second loop has V1, this is number 2. So let's we can bring this down a little bit. Okay, now finally in loop 2 we have V1, we have V2, and we have V3. Look at I3. I3 is going like that. So again, I'm gonna remove all of that, not to confuse ourselves. I3 was given like that, with that direction, which is going like that. So the voltage across the 1 kilo ohm is like that. Let's call it V3. So the third voltage here is V3. So let's now apply KVL. So if we look at the positive, V1 going from down because the direction of the voltage from negative to positive. So it is in the same direction as the positive direction. The positive direction here is basically counterclockwise, and that's why I love this this example, because in a loop you can assume the positive is clockwise. Another loop you can assume the positive is counterclockwise. Whatever you want, it's very easy. You can both can be counter, both can be in clockwise, both can be opposite to each other, whatever you like. Okay, is it same thing? So V1, or let's do it with yellow. V1, or so V1. V3 is also in the same direction, so plus V3. Now V2 as usual is negative. It's opposite as usual. It was also opposite in the first one. Equal to 0. Okay. V1 is unknown. V3 is I3 multiplied by 1 kilo ohm. I3 is minus 1.8. So minus 1.8 milliampere multiplied by 1 kilo. Minus V2. V2 is I2, 3.3 I2, 3.3 I2 equal to 0. Remember, I2, we have it. This is I2. So V1 minus 1.8, of course 1.8 multiplied by 1 is 1.8, minus 3.3 multiplied by 2.356. Okay, equal to 0. So basically V1 finally equal to 1.8 plus 3.3 multiplied by 2.356. Let's calculate that very quick here using also Desmos. 1.8 plus 3.3 multiplied by 2.356. That's 9.574 volt. And that's correct. I know the correct answer. Okay, guys, that was it. It is long because I explain in very detail, because I know this is maybe the first experience for you with big circuits, or like, a circuit, basically. Okay, not big. So I explain in very detail what is the direction of the the resistance of the voltage of the resistance, why is the ground, the positive direction of a loop, Kirchhoff current law, Kirchhoff voltage law. Okay, guys, that was it. That's the first solution. In the second video, I'm gonna show you the same example with another much simpler solution. Thank you very much for watching, and see you in another video. Bye bye.